So we are going to talk about the last part of the electrodynamics is the alternating current, okay? The calculations about alternating current. We just discussed the first point. What is the first point mentioned here is state the advantages of using alternating current over direct current is there are two main points that we discussed. I just want to go over that. The first one is it is easy to convert, okay, from AC to DC, and the second one is okay, the first one is it is easy to convert, and the second one is you can transmit over long distance, and then you will lose less energy, okay? So there will be less energy, less amount of energy lost when you use alternating current, okay? And then that's why, because you can easily convert lower potential to higher, higher potential to lower when it is AC, okay? And the next point, sketch the graphs of voltage versus time, current versus time for AC circuit, okay? That's what we are going to discuss. And there is something called RMS. RMS means root mean square. Can I just type it here and then you can see what is RMS? Root mean square. So what is root mean square? Root mean square is basically average. We know that alternating voltage and alternating current, there is no stable one current and voltage. It changes from 0 to maximum point, maximum to 0, again 0 to negative maximum to 0 again. So the voltage and current is changing all the time. So to be able to do calculations in alternating current, what do? We find the root mean square. That's basically an average, okay? That's the average between 0, a number between 0 and maximum. It's not half, average, okay? And what is the definition for alternating current? RMS for alternating current and alternating voltage. The RMS value, root mean square of AC, is the DC potential difference current which dissipates, uses the same amount of energy as AC. So when I convert the AC into DC, the value of AC into DC, how much power is used in DC, okay, is the RMS value in AC, okay? So how much power is used in AC voltage when I convert it into DC, that is the number, okay? So basically it's the average, okay? It's the average value of AC. And then there are three formulas that we need to know here. So this is the average current, or RMS, root mean square of current. This is the maximum current divided by square root 2. And if I know the average current or root mean square potential, and that's equal to maximum potential. Sometimes we call also this as peak value, okay? Like this, peak. Peak means maximum, okay? Sometimes for current also they use peak, okay? That's the same thing actually. Peak value of the current, you can also use it for the current. And then divided by square root 2. This is the first formula. And the second one is, for example, when you want to calculate the average power used by the AC, okay? So how can I calculate? That is the IRMS times VRMS. We know how to calculate IRMS, we know how to calculate VRMS, and then you just need to multiply by these two, okay? So P is equal to I times V, already know this one from electric circuits, okay? You just convert that one for AC is P average is equal to VRMS times IRMS. And then by using R is equal to V over I, you know this Ohm's law formula, and then you can calculate, you can convert VRMS times IRMS into this, okay? This one, into this one, and then also into this one. So these two formulas are coming from, okay, P is equal to I times V, and then you combine that one with R is equal to V over I, okay? And then when we look at the, I'm just using another color, I don't know, yes, find that. The potential difference for an alternating current is therefore defined by root mean square of the maximum potential difference Okay, where is that? So this is the graph for potential difference versus time or angle. Okay, it's the same graph for the time. And then where is the peak value? If you ask me, where is the maximum value of potential? Where can I find it on the graph? This is the maximum peak value. This is the maximum peak. Okay, this is also maximum peak. Okay, if this one is 300 volts, the second one is also 3, third one is also 300, and the fourth one is, this one is just negative 300. The poles are opposite. Okay, so can I just write down here, this is the peak value. Okay, and this is the negative peak value. Okay, this is the negative peak potential difference. What about the RMS? Where is this RMS? RMS is somewhere around here, not in the middle. This is the RMS value. So this is the V RMS, somewhere around here. Okay, and then if you just look at somewhere around here, similar point for the negative side. So this is going to be the negative V RMS. And the current, so if they give you a graph like this, we know what is V peak, okay, or V maximum, what is negative V peak or negative V maximum. The current for alternating current is defined as the root mean square of maximum current, similar to that. And then if I look at here, this is the peak current or the maximum current. This is negative peak, negative maximum. This is positive peak, and then this is the negative peak. Can I just write it here? I maximum or I peak. And this one is going to be negative I maximum. Okay, can I just write? Sorry, I'm using my mouse, very hard to. Okay, I managed. And then what about root mean square, the average of this? Because always when the time goes, angle changes, okay, rotation changes. What happens is that the value of current is changing from 0 to positive maximum, and then after that positive maximum to 0, and then positive 0 to negative maximum, and then it goes like that. So how am I going to do calculation if it changes all the time? I must just find the average somewhere around here, not in the middle, somewhere around here. That's what we call IRMS. Okay, this is the value that we are going to use. And how do we calculate that? A simple formula, negative I RMS. What is that? You just need to write down that peak value here. There's peak value here, okay? And then divided by square root 2. And then if I want to calculate V RMS, what do I need to do? I just need to take that peak value and or V max. V peak, V max is same, and then divided by square root 2. That's going to give me V RMS. These values can be calculated from the maximum potential difference and the maximum current as follows. Very, very easy, okay? And what about the average? So average power, okay? I just want to discuss this, and then next class, what we can do, we can solve some questions, and then when we solve some questions, you will understand better. And then we have 3 more minutes. The potential difference, okay? How do we calculate the power, electrical power when we use AC? That's the point, okay? That's the point. And the potential difference and the current for alternating current fluctuates, okay, between the positive and negative maximum points. And the average potential difference and the current is 0. Sometimes it is 0, so which means that, does it mean that power is 0 all the time? No, okay? So the average power is used to define the potential difference and the current for alternating current, okay? We calculate average power. How do we calculate average power? By using this. This is general formula, okay? So IRMS times VRMS. How do I find IRMS times VRMS? IRMS is equal to I maximum divided by square root 2, and VRMS is equal to V maximum times divided by square root 2. If you multiply these two, you are going to get 1 over square root 2 times 1 over square root 2 is equal to 1 over 2 times I max times V max. And then by using Ohm's law, R is equal to V over I. Next class, I'll just type it out for you and I can show you that conversion. And then you can use this formula to be able to find the other two formulas. So you can convert P average is equal to V RMS times I RMS into I RMS square times R, or V RMS square times R by using Ohm's law, simple Ohm's law, okay? So to be able to calculate the average power in an AC source, what do I need to do? I need to know V max, I max, or V RMS, I RMS, okay? And then you do the conversion and the multiplication, that's all. Okay, looks like the time is up for us. Okay.